So welcome class, fifth semester polymer technology. I have been gone so long because I was suffering from coronavirus. Unfortunately, I recovered from that dreadful disease. So let's switch to studies, additives for plastics. Number one, plasticizers and softeners. We have already seen cross-linking agents, glowing agents, and colorants. This is the fourth topic, plasticizers and softeners. It has been common practice to blend plasticizers with certain polymers since the early days for the plastic industry when Alexander Parkes introduced Parkesine. When they were first used, their function was primarily to act as spacer between the polymer molecule. So what does the plasticizer do? Plasticizer increases the softness of the plastic. And how does it increase the softness? By acting as a spacer between the polymer molecule. More space means less energy to rotate and therefore more flexibility. Less energy was therefore required for molecular bond rotation, and polymer became capable of flow at temperatures below their decomposition temperature. Means even if you heat the polymer before reaching its decomposition temperature, it will start flowing because of the addition of plasticizers. It was subsequently found that plasticizer could serve two additional purposes. Apart from this, two additional purposes plasticizer can perform: to lower the melt viscosity and to change physical properties of the product, such as to increase softness and flexibility and decrease the cold flux temperature. So number one is melt viscosity and change the physical properties of the product so as to increase softness and flexibility. And what is the cold flux temperature? A measure of the temperature below which the polymer compound loses its flexibility. Today, plasticizers is used in a variety of polymers such as polyvinyl acetate, acrylic polymers, cellulose acetate, and most important of all, polyvinyl chloride. It was pointed out in chapter 5 that plasticizers were essentially non-volatile solvents. Consequently, they were required to have solubility parameter close to that of polymer and a molecular weight of at least 300. So these are the some characteristics of plasticizer. If the polymer or the plasticizer has a tendency to crystallize, then there would need to be some sort of specific interaction between the polymer and the plasticizer. Gave some figures for solubility parameters of polymer and plasticizers. So you don't have to go much detail about that. Then of particular interest is the fact that two plasticizers of similar molecular weight and solubility parameter can, when blended with polymers, lead to compound of greatly different properties. Differing properties. Many explanations have been offered, to which the most widely quoted are the polar theory and the hydrogen bonding theory. So let us see what are these two theories. The polar theory suggests that plasticizers do not simply act as spacer, but form links, albeit possibly momentary, with the polymer molecule. So for a moment they form links between the polymer molecule and not just act as spacer. Dipole interaction is said to occur between a polar group on the polymer molecule, for example a chlorine atom forming part of carbon chlorine dipole, and a polar group on the plasticizer, for example an ester group, where there are links from the plasticizer to two or more molecules. A form of polar cross-linking occurs. Some molecules not only contain polar groups but may also contain polarizable groups such as benzene rings, which reinforces the polar linkage. A range of plasticizers therefore exists which have varying degree of polarity and polarizability. It is suggested that it is the difference that accounts for the different effects of highly polar and highly polarizable tritotyl phosphate and the less polar diortyl sebacate when used as plasticizer in PVC. The stronger linking of the phosphate tends to affect the spacing effect of a plasticizer, so that the resultant compounds have greater modulus and hardness and higher core flux temperature than would be expected through a spacing effect alone. So if there is a dipole moment, so means what, it is an addition to the spacing effect, means there will be more interaction, there will be more interactive forces, therefore the polymer will have hardness and it will have greater modulus, it will have higher cold flux temperature than would be expected through a spacing effect alone. So when a CBUS hit, the spacing effect is much less offset by any polar linking. So triotyl gives higher modulus and CBUS gives a little bit less. Doubts have been cast as to whether difference in polarity could account for such extensive differences in properties, and the hydrogen bonding theory is preferred by many. So there were doubts in the between the scientists that all these effects can be due to polarity or there is something else. So someone suggested the hydrogen bonding theory. This suggests that the link between the plasticizer and the polymer are through hydrogen bonds. In the case of PVC, the hydrogen on the same carbon as the chlorine atom is activated so that the polymer molecule acts as a proton donor. So read this line carefully. In the case of PVC, the hydrogen on the same carbon means the hydrogen which is on the same carbon as that of chlorine, because CH2 CHCl. So we are talking about that hydrogen CHCl is activated so that the polymer molecule acts as a proton donor. Certain chemical groups in plasticizer molecules are proton acceptors. In general, phosphates are strong acceptors, as also are esters and ethers. Aromatic esters are more powerful acceptors than aliphatic ethers. The intermediate position of the general purpose phthalates compared to phosphates and CBUSids can be seen in this context. In the rubber industry, hydrocarbon oils are often used to reduce the softness and facilitate the processing of hydrocarbon rubbers. These appear to have a small interaction with the polymer, but spacing effects predominates. Such materials are generally referred to as softeners. So what are softeners? In the rubber industry, we need to process rubber, and for that we have to make it soft. For that we use hydrocarbon oils, and because they often reduce the softness and facilitate processing. In our industry, hydrocarbon oils are often used to reduce the softness and facilitate processing. These appear to have small interaction with the polymer, but the spacing effect predominates. So hydrocarbon are often used to reduce the softness. These appear to have a small interaction with the polymer, but spacing effect predominates. Such materials are generally referred to as softeners. In rubber industry, like the plastic industry, common uses term plasticizer describe the phthalates, phosphates, and CBUSids. So what are the common plasticizers? Phthalates, phosphates, and CBUSids, which are commonly used with the more polar rubber. It has already been mentioned in chapter 5 that plasticizers are often replaced in part by extenders materials which in themselves are not plasticizers but which can be tolerated up to a given concentration in a polymer plasticizer system. Refinery oils and chlorinated waxes are widely used in PVC for this purpose with the prime aim of reducing cost, although the chlorinated waxes may also be used as flame retardants. So extenders are completely different. They are used in the polymer plasticizer system. Okay, because they want to reduce the cost, means you want to make more material, okay, and you don't want to put the original material, so you can add some extenders. But now in this rubber industry, hydrocarbon oils are often used to reduce the softness and facilitate processing. So I think the statement is wrong, because in rubber industry hydrocarbon oils are often used to increase the softness and facilitate processing, because hydrocarbon rubbers, uh, what does the softener do? As the name suggests, it should make the material more soft. So instead of reduce here, it should be increase. Okay. So that's all regarding plasticizers and softeners. In this, you have to know the basic idea of plasticizer, basic idea of softener, and you also have to know the polar theory and why it is ruled out, and then the hydrogen theory. So this all four things you have to know, then you can write easily about the plasticizers and softeners. I hope this is clear. Read it carefully, you will understand.